In this video, I would like to start a discussion about convolutional neural networks, which is another architecture of neural networks that we are going to see, specifically kind of engineered to address problems that we are facing in computer vision. I want to start this discussion with just showing you a picture. And if I ask you to tell me what would actually be the first object that you pay attention to, then most people will probably respond to with a yellow cab. And it's not really accident that a lot of cabs in a lot of capitals are painted yellow. And of course, that attention to bright colors originates from thousands of years of evolution, where people are, of course, trained to pay attention to bright colors, which are typically sources of food, such as fruits, or in some instances, sources of danger, such as the yellow tiger that is coming towards us. So, kind of joking aside, I think you can associate this kind of image with the following kind of processing of various kind of stage processing that is being going on in your brain, trying to, from the kind of perception system that embeds into it, that we have embedded into it. So if you can imagine the process, then the first thing that you open your eyes, as soon as you have your eyes closed, and you see an image like this, then the brain is actually in a first few milliseconds is sampling this image in a coarse kind of way, and determines whether we have situations such as an immediate kind of threat or a source of food. And then very quickly, the brain switches softly into objects, paying attention to objects which are associated with the task that we have to execute. So we have the, for example, if you're waiting for someone in this kind of a scene, then you start paying more attention to people coming towards you, people getting out of vehicles, and so on. So now what I would like to start getting into is the mechanics of a little bit of computer vision, some kind of basic principles. And I wanted to cover a little bit, the question as to, okay, what is an image, like the one that we've seen earlier, and how we're going to represent it. And evidently an image is a matrix. And I think we had some discussion about images before, and a black and white image is, or a grayscale image, as you actually see here over here, is a matrix of whose elements are integer numbers. And these integer numbers, typically, we are, each element corresponds to a pixel. And the dynamic range that we associate with, typically in computer vision, with those pixels are 8 bits. So we represent the information that each pixel encodes as 8 bits, which means that these integer numbers are from 0 to 255. And when we go to color images, we need more than one of those matrices. In fact, we need 3 matrices typically. Again, there are sensors which are, of course, encode the information to far more than 3 matrices, but those 3 matrices corresponds to the fundamental colors, typically of red, green, and blue. And this, which is actually what you see here. And also probably you notice that these numbers are now floating point numbers, let's say from 0 to 1. And this results from normalizing these pixel numbers with a number 255, because 2 to the power of 8 is 256. And therefore all our numbers will be from 0 to 255 in those matrices. If we start dividing every element with 255, we get numbers between 0 and 1. And this is basically what we need to do in order to process the images with our new neural networks that we will introduce now, called convolutional neural networks. So with convolutional neural networks, we need to start the discussion on what is a convolution, and this is what's coming next.